Hi everyone, Assalamualaikum warahmatullahi wabarakatuh. My name is Fauzi Maulana. I made this video for major assignment 1 in natural language processing subject with Mr.Handrie Noprisson as the M.Kom as the lecturer. This video is about Q&A basic of natural language processing. So let's move on to the first question. The first question is, what is the definition of NLP? Natural language processing, or also known as NLP, is a part or branch of artificial intelligence that focuses on how humans can communicate with machines by using human language itself. First, the human language is processed by the natural language processing program, and so the machine can understand what the users need. Next, apart from the text segmentation, what are the challenges of data processing or research in the field of NLP? Yes, the challenges are always there, we cannot avoid it, but we should face it. The challenge of the data processing or research in the field of NLP are contextual word and parts, synonyms, irony and sarcasm, ambiguity, error in text or speech, slangs, domain-specific language, low research language, and then the last one is lack of research and development. The third question is, what is an example of implementing the NLP in a software? Nowadays, I think so many applications that are already implementing the NLP because it can help users easier to use the application. For example, the Microsoft Word that use NLP for detecting the grammar mistakes and then give the advice directly to the user the right grammar. And then the other example is personal assistant application like OK Google and Cortana in Windows that can understand what the user said automatically. The next question is, what is the use of NLTK and subscribe libraries? The NLTK library is used for help the computer to analyze, pre-process, and understand the written text. NLTK consists of the most common algorithms such as tokenizing, part of speech tagging, stemming, sentiment analysis, topic segmentation, and name entity recognition. And then about the Sastrawi library is a simple library which allow us to reduce inflecting word in Indonesian language or Bahasa Indonesia to their base form or called stem. Despite its simplicity, this library is designed to be high quality and well documented. This library is implementing the Najib and Adriani algorithm. So, the next question is, what is the purpose of scaffolding? The purpose of scaffolding is to converting all the characters in a document into the same case, either all uppercase or lowercase, in order to speed up comparison during the indexing process. For example, the user would like to get the information about cat, and then the user type it cat like this, or cat like this. So, but still given the same retrieval result, that is cat with all the lowercase. A scaffolding changes all letter in a document usually to lowercase like this, and then only letter A through Z that are accepted. Character other than letter are removed and considered delimiters. The next question is, what is the definition of tokenizing? Tokenizing breaks down a set of characters in a text into words units. How to distinguish certain characters that can be treated as word separators or not. For example, white space characters such as enter, tabulation, space are considered as a word separators. However, for a single quote character, period, semicolon, double point, or others can have quite a number of rules as word separators. In treating the character in the text, it really depends on the context of application being developed. This tokenizing word will be more difficult if we also pay attention to the structure of the language, or called grammatical. Next is, tell me about stopword and give the example. The stopword are a non-descriptive word that can be discarded in a back-of-word approach. A stopword are a commonly used word such as the, a, and in that would be neglected in processing, and they are usually stored in stop lists. The main goal in implementing the stop-word removal process is to reduce the number of words in a document, which will later have an effect to speed and performance and NLP activities. Next, what algorithm that can be used for stemming Indonesian text and explain. The algorithm is called Nazif and Andriani algorithm. This algorithm is created by Bobby Nazif and Mirna Adriani to find the root word, or called stemming, of Bahasa Indonesia. First, this algorithm will search the word that we want to stem in the library. If it is found, and then the algorithm will assume that this word is already the root word. But if it's not, the algorithm will remove the like lah, kah, ku, mu, nyai, and kan, or those are called penurunan akhiran in Bahasa Indonesia. And then the algorithm will remove men or me, etc., or those are called penurunan awalan in Bahasa Indonesia. After that, the process is finished. The next question is, what is the purpose of word embeddings? The purpose of word embedding is as the word representation that bridges the human understanding of language to the machine. Word embeddings are distributed representation of text in an n-dimensional space. These are essential for solving most NLP problems. The importance of words embedding in the field of deep learning becomes evident by looking at the number of researchers in the field. The next question is, state and describe the architectural model of word-to-fact. Word-to-fact is one of the most used forms of word embedding. There are three main building blocks which make up word-to-fact itself. The first is vocabulary builder. This model is the basic building block of word-to-fact model. This takes the raw data in the form of sentence and extract unique words from them to build the vocabulary of the system. And then the next is context builder. This is the next level to convert words into the vector. The output of this, in example, the vocabulary object which contain the index and count as input. This not only takes the particular word but all the words in the range of context window. Context window is the know of words which has to be considered while taking in the input. Or generally 5 to 10 words are considered as standard. The last one, or the third one, is neural network with 2 layers. This is the most basic form of converting words into the vector. The size of this vector is the number of words in the vocabulary. On each word is assigned a unique vector. The position of the word that it presents itself is encoded as 1, and all other positions are encoded as 0. And then the next question is, what is the definition of bag of words? The bag of words model is the simplest form of text representation in numbers. Like the term itself, we can represent a sentence as a bag of words vector, a string of numbers. In the bag of word approach, we use the tokenized word for each observation and find out the frequency of each token. For example, I have 4 sentences here. I love you, I miss you, I need help, and I need you. And then we treat each sentence as a spread document, and we make a list of all words from all the 4 documents, excluding the punctuation, and then we get I love, you, miss, need, and help. And then the next question is, tell me about the fast text algorithm. The fast text algorithm is an open source or free library from Facebook AI Research, or called FAIR, for learning word embedding and word classification. This model allows creating unsupervised learning and supervised learning algorithm for obtaining vector representation for words. It also evaluates this model. FastText supports both Chibo and skipgram models. The use of FastText are used for finding semantic similarities. It can also use for text classification, for example spam filtering, and then it can train large dataset in a minute. FastText is very fast in training word vector model. We can train about 1 billion words in less than 10 minutes. The model built through deep neural network can be slow to train and test. This method uses a linear classification to train the model. And then the next question is, what is the meaning of n-gram? N-gram are extensively used in natural language processing or NLP tasks. An n-gram model predicts the probability of a given n-gram within any sequence of words in the language. If we have a good n-gram model, we can predict what is the probability of seeing the word given a history of previous model where the history contains n-1 words. When developing a language model, n-gram are used to develop not just unigram model but also big-gram and t-gram models. Google and Microsoft have developed web-scale n-gram model that can be used in a variety of tasks such as auto-completion of sentence, spelling correction, word breaking, and text summarization. The next question is, describe an example of applying n-gram. The example application that use n-gram method are as follows. The first is Gmail or Google Mail. The Gmail or Google Mail use the n-gram method for auto-completion of sentence when you want to compose an email. The second example is Google or search engine. The Google use the n-gram method for word predicting what is word that we will type for completing our sentence. And then the next example is Microsoft Word and Grammarly. These both applications use the n-gram method for spelling correction and check for grammar in a given sentence. And then the next question is, what is the definition of smoothing? Smoothing are used to address scenarios related to determining probability or likelihood estimate of a sequence of words occurring together when one or more words individually or n-grams such as big-gram or trigram in the given set have never occurred in the past. The application of smoothing is very important in natural language processing, as some words may have zero or close to zero probability, such as the out of vocabulary word or word that doesn't exist in the vocabulary. But the same rare word may not have the same values in the test data. Smoothing enhances accuracy in statistical models such as naive Bayes when applied to data with high sparsity. By removing the penalty on zero probability n-grams, the problem is with the really zero probability or the ones that are really zero. Next is, tell me about lapless smoothing. The lapless smoothing, or sometimes called at-once smoothing, in this type of smoothing, one is added to all the count and thereafter the probability is calculated. This is one of the most trivial smoothing techniques out of all the techniques. Maximum likelihood estimate, or MLE, of a word occurring in a corpus can be calculated as the following n. N is total of number of words and then count of words for whose probability is required to be calculated. Next is, what is the definition of backoff and interpolation? So let's say you are using program to calculate the probability of a word in text. You have this is very followed by sunny. Let's say sunny never occurred in the context. This is a very. So for the foreground model, sunny has probability 0, and that's not good because we know that sunny is more probable than say giraffe. Backoff means you go back to a n-1 gram level to calculate the probability when you encounter a word with probability 0. So in our case, you will use a 3-gram model to calculate the probability of sunny in the context is a very. And then the interpolation is the opposite of the backoff. There are ways used in interpolation, or that sum to 1 and can be calculated from corpus itself via a variety of methods. And then I found the difference between backoff and interpolated model here. Both of them, in determining the probability of n-gram with non-zero count, interpolated model are use information from lower order distribution, while the backoff model do not. In both backoff and interpolated models, lower order distribution are used in determining the probability of n-gram with zero counts. Wow. So the next question is, explain why the Kearney smoothing method performs so well. I have found the Kearney smoothing method performs so well because the modified backoff distribution that Kearney smoothing employs. Kearney and Ni have introduced an extension of absolute discounting where the lower order distribution that one combines with a higher order distribution is built in a novel manner. Next is, what is the background for the development of the stupid backoff method? The stupid backoff gives up the idea of trying to make the language model a true probability distribution. There is no discounting of the higher order probabilities. If a higher order n-gram has a zero count, we simply back off to a lower order n-gram weight by a fixed content independent weight. And then this is the last question. The last question is, what is the rationale for the good Turing smoothing method? A good Turing method provides a simple estimate of the total probability of the object not seen. How this probability is divided among the objects depends on the objects, especially on any structure such as the component word of a bigram. The object may have a good tuning method are also estimate probabilities for observed objects that are consistent with the total probability assigned to the unseen object. These probabilities for the observed object have not been easy to estimate and may have differed many from using good Turing methods. The rationale of good tuning smoothing is to use the count of frequency of something that has been seen once to help estimate the frequency of something that have never been seen. A single word of n-gram or even is called a singleton. In order to calculate the singleton frequency, we need to calculate nc or c times the number of occurrences. At good Turing, there is an assumption that all words are binomial distributed. For example, nc is the number of items with frequency in c times the frequency of frequency. Then the nc can be used to provide a better estimate of c. So that's all for me. This is the last part of Q&A of basic natural language processing. Thank you for watching my video. See you.